Oh, sorry about that. Yeah, number 6. Like I said earlier, I'm brushing up on my virtual work, virtual forces, virtual displacements as well. And for some reason, I thought number 6 was extremely complicated, but it's not. It's just the same thing. Use the same procedure as in number 5. Find your moment in this beam. Find your moment in this section and in this section. And so look at it like yeah, you're gonna break this up in 2 parts again. Remember how before we were summing forces, we made a table? We're gonna do something a little bit similar, so you're gonna find this is A, B, C. So you're gonna find equations for right. You're gonna do what do you want? You want the rotation at B, horizontal displacement at A. So I'll do the horizontal displacement at A. You can do the rotations at B. I'll just set this up. You have this set up here. You want to use a similar system. You want to see what moments develop. What develops in here? Your 1 kip. You're gonna. So I'm getting ahead of myself. You have MAB of x, MBC of x, MAB of x, MBC of x. Your delta A is going to be equal to the integral MAB times MAB over EI plus integral of this is your length from A to B, from B to C. It doesn't actually matter where you start. So if you start your moment equation from here, if you start your moment equation this way, you're going to have A to B. If you start your moment equation this way, you're going to have B to A. So it only depends. You're starting from the beginning to the end. You just, as long as you just want the entire beam, because what does integral do? Integral is actually taking the area. So as long as you're consistent, it doesn't matter what signs you have. Well, the signs do matter, but as long as you're consistent with your notation, the signs will all make sense. BC, so this is M, BC, M, BC over EI. And the question is asking for 2 parts. First, it's saying ignore axial deformation. And that's what this is doing. This is ignoring axial deformation. If you want to include axial deformation, I believe all that means is you go back and do the same procedure you did here. The same, sorry, not here. The same procedure you did for number 1. Yeah, you apply axial force. Well, like any of these procedures, they're pretty much the same. Just apply an axial force, and sorry, this is only including bending. You have axial forces that develop in here already that you haven't taken into account yet. Because this is only including moment. You have axial forces, so you just add your axial forces. FAB, FAB, FAB over times L over AE. Yeah, and you're given A, E, and I. So you can do all this. And you can find the length just by trig. I don't think it showed up here, but this should be a 3, 4, 5 right triangle. Okie doke, but yeah. I don't know. I'm sorry about these videos. I feel like they're not exactly up to par compared to the previous tutorials. I had my midterms this week, so I wanna relax too, and I just want to make sure that you guys get these before it gets too late, because I want you to get a head start on this for so you can see me in office hours. Not just me, see one of us in office hours. But yeah, definitely let us know if you have any questions. I try my best to respond to questions as quickly as possible. There was one person this weekend where I felt really bad that we kept missing each other, so I ended up getting closer to like 24 hours before I emailed them back. But usually I try to email you back within the hour. I really do. I think some of you noticed I didn't return it immediately, but yeah, feel free to let us know if you have any questions. Yeah, good luck. Have fun.